In this video, I'll be showing you how to get started with the code on the Jetson side of the electronic subsystem. So first you will need to be on a Linux environment. So I will do it under Windows just because I don't have access to a Linux environment right now. But you can use, for example, Windows subsystem for Linux and install the correct installation of ROS on it. But I will just show you and walk you through the code. So first, you need to go to the repository. So the repository that we use is EL workspace, which stands for electronics workspace. So this is a ROS repository, ROS workspace. It's located under the EPFL Xplore organization as usual. First, you need to clone here the repository. So let's do this. I am inside of my usual folder and I will just clone this. All right. So just do like this. All right. So now I can just look at the status. So normally I should have everything. So let's go first in this git status. So there's nothing here. Also, I need to update the library. So because I am using also on this repository, we are also using Broco as a library. Here you can see that it's pointing to this commit here. So now let's just update the library to get all of the files. So we do git submodule update init remote. And I just need to type in my password. All right. And once again. Okay. So you can see that it checked out the last version of Broco. So if I go inside of Broco, and then you will see that it has checked out the version, not this commit here, but it has checked out the last commit. So I go in Broco, and if I go in the commits, you can see that it has checked out the 13AE4FF. So it's the 14AE4FFF. So now if I do git status, you can see that it's asking me if I want to update the library on the repository, because it was previously pointing to this commit here, and now that I've updated it, it is pointing to this commit. So I need now to just update the reference. So I can just do git submodule git. Wait, this is not the correct one. So I can just do git status and git add source Broco, and then I just do git push. Okay. So now everything is up to date. And if you look at back at the workspace here, so it was in electronics workspace, you will see that I am pointing to the correct commit. Well, there is some issue here for some reason. Oh yeah, I forgot to commit it, of course. Git commit m updated lib. Okay, now git push, and it should have updated the library. Okay, I just reload this page, and you can see that it's pointing to the right commit now. So now that you have updated the lib on both sides, if you want to use it, you can do a colcon build. So here I can't do it because I'm not on Linux, but you can do colcon build and it should build the library. But first, let's just look at the code, and I will explain to you in some detail what is happening and what is how everything is working. So let's look first at the code. So first here you can see the Git modules, which are the library that I've added, and the Git ignore, which are all of the files that we don't really want. In the source, you will find all of the different packages that we have defined for our ROS package. So here in the bro code, this is the library that we have just added. So this is the same one as the one that is on the microcontroller. So as you remember from the getting started with the communication protocol video that I did for the microcontroller, we actually added a new packet um, on the protocol, which was the dummy packet. And this is why I had to update the library on the Jetson. So I actually added here in this new packet here, which was the dummy packet. And to be sure that we had the same library on both sides, I had to update it here. So if I go now in the source and in the CAN bus, I will be able to see here the new packet that I added. Okay. So this is the library that we have. Now, let's talk a bit about how everything works. So if you are not familiar with ROS, you should have a look at how it works first, of course. And so I will assume that you already have some knowledge about ROS and that you already know how things work, like very basically with the publishers and subscribers and with the workspace and the packages. But I will still try to walk you through very briefly so that you can somehow understand it, even with very basic knowledge. So the entry point of our program is in the avionics main. So in the avionics main, you will see a launch folder here. And the launch folder is basically a launch file which will be executed to launch the whole avionics code. So I will show you a video that will show you in practice how this works. But basically, you don't really need to know this, but what you need to know is what it is launching. So here you can see the different nodes that it launches. So it first launches the configuration node, which is given by these parameters. Okay. So the config package name here is avionics config, and the executable name is going to be the avionics config.cpp. So, or the avionics config here. So basically what this does here, the launch file, is it launches all of the executable that we want for our whole project to work. So we will be running here the configuration node. We'll be running the ROS interface node. And you can even see that we will be running it twice, once with the bus 0 name here, and once with the bus 1 name here. So we'll have twice this node. Afterwards, we'll be running the avionics mux node. So I will explain in detail what all of these nodes are. And in the end, we'll be running the avionics converter node. So you can add your own node by just looking at this and adding it at the end of the code if you want to write some more code and more packages and stuff. Okay. So this is the gist of how the code is structured. So now I'll explain to you what every part is for and how it works in some detail. So the most important part is the ROS interface. So what this does here is it will get messages from the microcontroller through the ROCO bus network that we've defined. So if you remember, it is working on the using the CAN bus, and then it will convert it to ROS messages. So ROS subscribers or ROS publishers. So first, something that you need to do is to go in Broco, include build, and you need to make sure that you have the correct build, build defined. So because we are working on the Jetson, we want to have this defined and this commented, right? So this is okay here. Then you will go in. Let's go in the ROS interface. So we will have multiple files here. So the starting point is this file, the Roku interface. The Roku interface here creates a Roku interface node and also creates a broker manager node. And the broker manager here, the goal of this is to first get some parameters which are defined in a configuration file. So these are just parameters with values inside. It will then connect um, the it will then connect to the CAN bus. So this is done through our custom driver, which is the CAN socket driver, which uses functions from the CAN socket, the FNCTL and the CAN and the socket functions from Linux. So if you want to have more details, you can ask me on Slack. But normally this should work pretty well. So we've written all of this from scratch, and you need to read in detail the documentation about how to use the CAN bus on Linux to fully understand how everything works. But yeah, so it first creates, it will create a driver on the CAN bus. So you can see here that we connect to the CAN bus given this parameter. So this parameter was the one that we gave here. So it was either bus0 name or bus1 name. And we created the node here, the node ROS interface, twice. So once with the bus0 name and once with the bus1 name. So basically this node ROCO interface will be created twice, and one for the CAN 0 and one for the CAN 1, so that we can have two CAN buses which will communicate with our board through the two buses, so this one and this one. Okay. Once we have created these, what it will do is it will create the publishers and the subscribers. So this is, you can see that if everything is has been correctly created, it will call this function. So you can see here that if it is connected to the bus, it will create the publishers and subscribers. And this is done by creating two new objects, one Broco publisher and one Broco subscriber. Let's look at what these are. So the Broco publisher and Broco subscribers, as the name implies, just create publishers and subscribers. So in our case, we want to create a separate publisher for each different type of message that we want to have. So, for example, I was talking before about the IMU message. So here we can define a new publisher which will publish on the IMU message. So we do this for every type of message that we want. And then we also need to create a handle. So why do we create a handle? This is from ROCO, the custom protocol that we have. So this is because we want to have a callback function on the CAN bus. And from this callback function, we will then publish the data on a ROS topic. Okay, so the microcontroller will send data on the CAN bus. Then this will be triggered, like one of the handle functions will be triggered, which will then publish the data onto the ROS topic. So let's have a look at some definitions. If you look at the publishers, we just use the standard syntax for creating a publisher. Here you can see that I also have defined some parameters. So instead of giving the name of the topic explicitly, I get the parameter from a certain file. So these are defined in the configuration file here, and you can have a look. So for example, the voltage topic is defined in the topic params names, and it is defined here, voltage topic. So you can have a look at these parameters if you want. So I was in the Broco publisher. So here we just create all of our publishers, and then we need to create all of our handles. So the handles are pretty straightforward. We just create a handle, we register a handle, and then add our function, that the callback function that we want. So in the case of the IMU, for example, we do a handle, then we give the type of packet, So this packet here is the one that we defined in the Broco library, if you remember. So it is defined somewhere here. It's an IMU packet here. It has an ID of 6. And it was defined here as well as in the protocol 23.h. And it was registered in the protocol macro.h. And the protocol register.h, I mean. So here we just handle the packet and we give it the function that we want to call when we receive the packet. In this case, it's the handle IMU packet. So if you go inside, you'll see what it does. So the structure here of the handle is very similar. It's actually identical to the handles that we saw on the microcontroller. So when we were working on the servo thread, for example, here in the servo thread, you could see the handle was very, very similar. So handle, and we had here the sender ID as well as a pointer to the packet. So this is exactly the same. We have the sender ID and the pointer to the packet. So as in a very similar way to the microcontroller side, we check if the packet is reliable by checking the CRC of our packet. And if it is not reliable, then we just exit this function. And otherwise, we need to create our ROS message and then publish it. So in this case, there are many fields that need to be filled in the ROS message because we are using we want to really use the IMU message from ROS. So the IMU message here has multiple fields that we need to fill. So it has a header, quaternion, and all of this. So we need to fill all of these messages, and then we can publish it onto the publisher that we've defined before. So this is the gist of how the publisher works. You might have noticed, but we are using custom messages from ROS and not your standard messages. So I will also explain in some detail how this works. So we use our own custom messages from ROS here. Right now, let's go into the subscriber. So this is very, very similar. We simply define our subscribers here, and then we also define the callback functions for our subscribers. So what does this mean? This means that when we publish a message on a certain topic, which is defined by the subscriber, it will go inside of the callback function. And then in the callback function, we will send the message through the CAN bus using ROCO, which can then be intercepted by the microcontroller or other devices on the bus. So it's like the inverse of the publisher. In the case of the publisher, we received on the CAN bus and then published on the ROS topic. And in the subscriber side, we publish on a ROS topic, we receive it on a subscriber, and then we send it back to the CAN bus. So this is like the inverse of the publisher. So let's go in the subscriber.cpp so we can have a look at how everything is working. So you can see here that we just create a subscription. We give it the name of the topic for the subscription, as well as the callback function for that subscriber. So whenever something is published on that topic, it will call the callback function. So this is a ROS callback function. And then we can do some checks. So let's have a look at the servo request. So what we do here first is we will check for the destination ID. So I will explain to you in more detail what this is, but this is something in our message, our custom message. So the main gist is that like how it works in very briefly is that the ID here is part of our custom message, a ROS custom message. If the ID is equal to 0, then we will send it to the board that we think it is connected to. So this is hard coded. We know in advance which sensor has which board has which sensor, as you can see here from our diagram. So this is so that someone who uses someone from another subsystem can just publish a message on the proper topic and just give the destination ID equal to 0. And if he does it, then it will automatically send to the correct node on the network. Now, if we want to send it to another node, for example, if, for some reason, we decided to set the servo not on the handling device node, but we decided to move it to the nav node, then it is possible to fill the destination ID equal to 3, which will send it then to the navigation node. Right, so this is just an optional field that can be filled or not, depending on whether or not we want to use a default value or if we want to send it to another node. So this is the first thing that we do. And then I just print it somewhere in the terminal so we have some debug information. And afterwards, this is very similar to what we did on the microcontroller. So I just create a packet. And this is what I told you before, but you don't really have to create a data structure. So if you remember from the microcontroller side, when we were working, for example, with the mass thread, so let's go in the mass thread, we created both a packet but also a data structure. So I don't remember where it was. Maybe in the server thread. So yeah, if you remember, we created a server data structure as well as a packet. The server data was useful just because we could have some more functions associated with the data, like a string function to print it. But it is not necessary, and it is also possible to just create a packet and then access each field directly. So this is what we do. We first create a packet here, and then we just set the channel and the angle of the packet depending on the message that we receive on the ROS topic. Then we just make it identifiable, just like before, make it reliable. So this is just a way to set the ID. So we just hard-coded the ID to 0 because the Jetson has an ID of 0 as we've defined in this schematic here. So we just define the sender ID as 0 and we compute the CRC. And afterwards, we set the destination ID depending on where we want to send it. So in this case, it's defined by either this, so either a default ID, which would be this, or a destination ID. And then we will send the packet on the CAN bus. So it's a very straightforward way to send data from a ROS message that we receive on a topic. Okay, so this is the basic, the basic way of how we send data through the Roku ROS interface and how we receive data on the Roku ROS interface. Okay, that was for the first package. So now, if you remember from what I told you about before about the structure of the electronic subsystem, we are actually sending data on two buses, so on the CAN1 and CAN2 buses. So how do we actually know which data to use on the Jetson? Because on the Jetson, I will be creating two Roku ROS interface, one on CAN0 and one on CAN1. So CAN0 will be connected to FD-CAN1 of the microcontroller, so this one, and CAN1 of the Jetson will be connected to FD-CAN2 of the microcontroller. Yeah, they have different indexes, but there are two buses for each. So what we do here is we will basically create many topics. So I will have a small video showing you later what I mean by that. But here in the publishers and in the subscribers, we actually create a topic for each message that we want. And the topic will be also preceded by the name of the bus on which we are receiving it. So for example, let's say that I have the, let's say that I am working with the ping packet. No, not the ping packet, more like the IMU packet. Then what I do is I will create. So let's look at the IMU pub. I will create here a topic with the name given by IMU topic, but I will also give it a prefix here, and the prefix will be given by will be given here by return prefix. Well, the prefix is basically given by the bus name. Okay, so I could maybe try and show you if I type prefix here, and you can see here that the topic prefix will be equal to the bus, so either can0 or can1. So basically we will have many topics. One will be given by can0, this is the prefix. Then we'll have el imu, this is the first topic for our node which is created on can0, and then we'll have another one which will be on can1. So we'll have two topics like this, and they will each receive messages on their respective CAN bus, and they will each publish their messages on this topic. So now how do we choose from which topic we are getting the data from, and how to send the data at the end on the final topic? Okay, so what we do is we use a multiplexer. So this is the node here, which is avionics mux. So this node here is comprised of multiple files as usual. So you have the avionics mux.cpp, which will create a mux manager node. And as you can see here, the mux manager node will create a multiplexer for each data type that we want. So it will create a multiplexer for the IMU, and then it will choose which source to choose from, like either on the can0 bus or on the can1 bus, depending on the state of the node. So you don't need to know about in detail about what is happening here, but I will, in the video that will be coming shortly, I will give you an example of what I mean by choosing the data. But basically, what it does is it will, if you go in the broker manager in the publisher part here, you will see that there is a ping function. So here we have a timer ping callback, which is called like repeatedly. And what it does is that it will send data, it will send a ping to the microcontroller, and then the microcontroller will send some data, will send a ping back to the Jetson. And what it will do is that it will publish the states of the nodes, which is a list of a Boolean, it's a Boolean vector. And this Boolean vector for each index will be equal true or false, depending on whether or not the node is active. So this will be done for the two buses. So we will have one topic which will be equal to can0 el node state, and we have another one which is can1 el node state. So we have these two topics here, and depending on the state that we see on these topics, we can know whether or not there is an issue on the bus. So I will show you the video and you will understand in more details what I mean and how the multiplexer works.